Okay, so now we're going to specifically talk about the SD functions of the logger shield that we sent to you guys, and the library that we're going to be using. Okay, so we already have looked at sort of the overview of that GPS shield. We talked about all the other stuff, and we mentioned, oh, there's this SD card slot here, right? So it's in the corner. That's what it looks like, right? You put an SD card in there, right? The way that you actually talk to that SD card is using the SPI protocol. So remember, that's one of the synchronous serial protocols that we talked about. So we talked about I2C is the other one. This is SPI, which we have not used. We're not going to directly do SPI programming. We're going to use the library that will handle all of those communications in the background. Now, this particular slot will work with any size SD card, but the library that we're using will have to be compatible with that size and with that file system. And even if it's compatible with the file system, depending on the library, it may not have access to all of the storage on the SD card. So the way that this thing works is you slide it in, you'll push it in and it'll click. And then to release it, you push it in again and it'll eject it. So it's one of those, it doesn't just slide in and pull out. It's one of those, slide it in, it'll click, and then push it in again to make it eject the thing. The way that data will be stored on here is it's just going to be individual files like it is on a computer. We're going to use plain text files in here. But so always, and especially before a flight, you want to make sure that your SD card is fully inserted, that it's properly latched, because otherwise you're not going to get any data. Yep, so you can see, and you can kind of make out the actual little pin contacts on the bottom. It's right here next to the reset switch. And this chip right here is actually a level shifter because the SD card works on 3.3 volts, but your Arduino works on 5 volts. So this chip will actually convert your 5-volt logic signals to 3.3 volts to talk to the SD card. So if you remember when we first talked about this GPS shield, we talked about that it was basically designed to mount directly on top of an Uno. So because of that, it's connected to the Uno's SPI pins. And if you remember, SPI takes 4 different pins to do communication. You have 2 one-way data lines, which are the MISO and MOSI. You have a clock signal pin, and then each individual device, so in this case, the device is the SD card, has a chip select that basically turns on the device that you're talking to. So because this shield was designed to mount directly on an Uno, its SPI pins are pins 10, 11, 12, and 13, because those are the SPI pins on an Uno. And you can see they are marked on the shield. Clock, DI, that's the MOSI pin, because that's the input for the SD card. This is master output, slave input. And DO is the MISO pin, because that's the output for the SD card. And then chip 10 is the chip select. Unfortunately, on the Arduino Mega 2560, the Megas that you guys are using, those MISO, MOSI, and clock pins are pins 50, 51, and 52. Those are the hardware SPI pins. Because of that, you have to either make jumpers like you did with the GPS shield serial port, or you have to use a library that does software SPI. The chip select really isn't an issue. Most libraries let you freely select the chip select. That's basically a pin you just pull low and it'll activate that device. So you can pretty much, in most libraries, pick any of the digital pins to be the chip select, and you just pass that as an argument. But because you need the actual, clock and register and all of that stuff for the hardware SPI, those you would have to actually connect, or like I said, one of the reasons we picked this particular version of the SD library is because it allows you to simply implement a software SPI. So this SD card library that we're going to use, we're going to have to manually install. This is the link where it is available. So basically, it's an old Adafruit fork of the SD library. If you go there, you will have, this will take you to a GitHub repository, and we're going to walk through this during the activity. You download the zip file of the library, you copy it into your libraries folder. You'll have to rename the folder from SD master to SD. And as a reminder, the default location for that libraries folder is documents, Arduino libraries. Again, that's inside the sketchbook folder, which you can set in a preference. Now, the reason that we chose this particular older SD card library is it lets you easily define software SPI. You basically, when you create the object, you just have to tell it which 4 pins you're using. Unfortunately, this library does have some limitations because it's an older library. And another thing you need to be careful of is Arduino loads the libraries when you start up the IDE. So if I already have the IDE open and I do all of this manually install of the library, I have to restart the IDE before it'll recognize that installed library. So the limitations with this library is you have to have either a FAT32 or a FAT16 library. A exFAT card will not work. And I verified that just today with a 1 terabyte card. Additionally, even though the 32 gig cards do work with the library will only be able to see about 2 gigs of the storage. So if I like do a query where I'm trying to look and see the available storage, it will only see about a little bit under 2 gigs of storage. Additionally, you have to name your files using the old 8.3 file naming format, which means 8 characters before the period or decimal, and then a 3-character file extension, right? So no spaces, no file names longer than 8. So if you try and do that, it just will not work. Also, because this is a software SPI, like we said, any software implementation of a communication protocol is going to be slower. And most importantly, if you are then going to try and do other programming, is this will override the default Arduino SD library. So this has the same name. They're both called SD.H. And the way that the libraries work is it will look and see if there's a library in the sketchbook libraries folder with the same name, that will override the default version. So if you're going to try and do some programming where you're wanting to use the default Arduino SD library, you need to copy the folder out so it doesn't load. So like I said, you have to have follow this particular naming format for your files. So you can see here, I have the actual file name. Conveniently, file name is 8 characters. You need a decimal point or a period, and then a 3-character extension. You can make it shorter than 8 characters, but you can't go longer. And you always want to include that extension. The extension basically tells you on your computer what program you want to open the file with. So in general, what we're going to be using is .txt, which indicates it's a plain text ASCII file. So that will open in like Notepad or just any kind of text editor. And we'll use .csvs for comma separated values. And we'll talk about those in a little bit later. In general, you want to try and use file names that are useful. Don't just call it data. You could, for example, once you've got your GPS working and all of that, you could give it a date or a timestamp as part of this file name. You could sequentially number your data record files, right? The idea is you want to try and use the file name to help you out, help organize your data. You can use letters and numbers, an underscore or a dash, but other than that, don't use other characters, except for obviously the period between the file name and the extension. Don't use spaces. And then obviously don't use extra periods because that just confuses it. And then in general, stay away from weird characters like $signs, ampersands, pound sign, just to make your life easier, to make sure everything works. Stick to mainly letters and number characters. So, like I said, we're mainly going to use either .text or .csv. In particular, for data storage, .csvs are what we recommend you use for your actual data files, especially when we get to the second semester with flight. So CSV just means comma separated value, right? So it's simply a way of breaking your data into separate fields. So I could have information, a particular number, a comma, then a second number, and another comma. So basically, I just have a bunch of fields so each line is a row, and the commas break it up into the columns. And what's convenient is, in particular, is that you can just open a .csv directly in Excel, and it'll open up a spreadsheet, and it'll organize it into rows and columns. Really, CSVs and texts are the same format. They just have a different extension. So a CSV on a Windows machine with Office installed will automatically try and open up in Excel. I could easily rename the CSV to a text and open it up in Notepad, or I could right click on one of them and manually, tell the program to open up the other one. But naming them .csvs makes your life a little easier. So when we start working with actual data, you want to think about how you're wanting to store that. And like I said, what we recommend doing is record your data in plain text, so as a bunch of ASCII characters in CSV files, which means if I need to store the number 5, I want to store an ASCII 5, or I want to store the number 1.5, I will store the character 1, the character period, and the character 5, not like a floating value. Now, you could store those like floats and binary and integers as those data types in a file. That would be basically what's called a binary file type. But then everything has to be very regimented, and you have to basically design your own file type. So that's tricky. And also, if something goes wrong, it tends to break the entire file. Whereas if I'm using just plain text format and I have a write error where this 2 was written incorrectly, I'll just get a weird character where that 2 is. The rest of the data will work perfectly fine. Also, the SD card library that we're going to start you guys out on, it uses the exact same format for doing writes as the serial libraries do. So like print and print line, and you just send it text. So that is a common interface that hopefully you guys are becoming familiar with right now. You want to use commas to separate the data into discrete spots. That lets me, if, for example, I didn't transmit this 0 and I was just saying all of my numbers without any spaces in between the two, if I have an issue on one of these and it shifts everything off, now my data is all out of whack and I don't know where the pieces of my data are. Whereas if I do this way, I have nice, clear delineations between each data field. And then the other sort of general recommendation is you want to use a header, which is just going to be labels at the very first line of the file, right? And that will tell you, it makes it easy when you're just opening the raw data to be able to tell what data is what. So you're also going to want to think about how do you need to actually store the numbers in the file? How many decimal places do you need? Do you need to include positive and negative signs? Do you need to include units? A lot of times you don't really need to include units, but you'll probably want to put the units in the header so that you can read it. Another thing is if you have data that's being recorded at multiple rates, say I'm recording a temperature every 5 seconds, but an altitude every 10 seconds or something like that, right? It's easier to just basically have the standard row where you have spots for all of that data, and you just don't record a number in the row if that's one of the data packets where you're not recording a temperature or an altitude, right? That way I don't have, I can look, when I open this file up, I can look and I'll just have blank spots at the times where I wasn't recording that particular number, rather than having multiple different data types and now I have to worry about trying to sort those out, right? So this is sort of just a quick example. So my data record is I've just got a number that I'm using to identify it. I do have a type marker, so I have data that either has A or B type, and the difference between those two is if I'm recording the temperature or the altitude. And then I have some sort of time information. This is sort of generic and vague, so that could be a GPS, that could be a millis, or it could be anything, right? So this is sort of what my header would look like. And then you can see, like, here's my first data row where I have number 1, type A, time is 3, whatever. And then I have my 2 temperatures, but I don't have an altitude, right? And then a little bit later, I have another temperature packet or data line, if you want to think of it that way, right? Again, it's A, and I have 2 temperatures. But then a little bit later, I have my altitude, right? I've skipped the spots for my 2 temperatures. There's just nothing there. It's not a space either. I just haven't written anything. And you can see in the previous ones, I have that same empty spot for the altitude, right? And in this time, I'm actually going to write an altitude number. So what I've done here is a few things. One, when I open this up in some sort of Excel or other thing, other data analysis software, I still have nicely shape. I don't have like altitudes mixed in with temperatures. They're going to be on separate columns. I also have given an easy identifier so that if I want to sort out all of the altitudes, I can do that easily by just looking for all the ones that have B's. If I want the temperatures, I look for all the ones that have A's. I've also given each one of these a unique identifier because I want to be able to tell this is all the data that was data packet number 1. This is all the data that was packet number 2, right? This is all the sort of stuff that you want to think about when you're designing how you're going to store your data for your payload in the second semester. So the way that we actually use the SD card library is like this. So first, as you can imagine, we do an initialization, usually in the setup. So we call, so the SD card, SD is an actual object that we declare, like the serial or like the GPS objects. And then we call .begin on it. And we pass it the chip select pin, the MOSI pin, the MISO pin, and the clock pin in that order. All this, when you do this, there will be a quick check by the library, making sure that it can actually talk to the SD card. So this will actually return a Boolean value. So if it has a communication error, you'll get a 0 back. And during the activity, we're basically going to use that to be able to tell if there is an actual SD card installed or not. Once you have this SD object initialized to this SD card, I can now create a file object. So I call sd.open with the file name. And then the second argument is the mode that I'm opening in. So this is actually a constant that's part of the library. That's why it's all capital. File write. And that tells me that I'm opening this, this file in write mode. I'm going to write data to it as opposed to reading data. And you can see that what this is going to return is basically a pointer to the file object. So I set my file equal to this, right? So now whenever I refer to my file, it's going to be operating on whatever file I've named here. So to write, I call myfile.println, just like the serial monitor. This will add a new line and carriage return at the end. If I call print, it will just write the characters that I have in print, and it won't start a new line. One important thing that's a little bit different than the serial monitor is you have this flush function. So basically that sort of forces the write to happen before the program proceeds on. And that's going to be important because if you don't do this, the write may not complete. You may do other stuff in the program. So in general, after you do a bunch of writing, you want to call one of these flushes. And then I can close the file, and that basically breaks the interruption, the link between the my file object and the actual file on the SD card. You can get away with not closing the file, but in general, it's good practice to close the file. But the actual write happens when you do this. So if I had like a power interruption before I got to there, I should still be able to open the file. But these are your basic tools we're going to use for writing data. So like I said, there's a whole bunch of limitations with this SD card library, but it's easy to use because with the SD card shield, because we can just pass it the pins. Once you get comfortable with this and you want to get a little more advanced, the library we would recommend is a library called SD-FAT. It's you can either manually install it or it's in the Arduino library manager. And that's basically going to remove all the limitations. You can use an exFAT, you can use a full-size card, but that's going to assume that you are using the Arduino Mega SPI hardware pins. So you would one thing you could do is you can install jumpers from those pins. And you do need to be a little bit more careful if you're making those jumpers. So because there's a synchronous clock signal, the actual length of the wires can matter. Whereas with the serial jumpers, because it was unsynchronous and the TX and the RX really didn't have anything to do with each other, they didn't need to be the same length. Because depending on the clock speed, you're probably going to be slow enough where it doesn't have to be like super exact the same length. But if you install jumpers and you start having problems, it may be because your leads are either too long or they don't match well enough. Now, this particular library does allow you to do software SPI, but it's a bit more complicated than what we have done here. You basically have to go into some of the library files and modify some of the constants. But like I said, once you get used to this, and if you need more advanced capabilities or faster write speeds, this is probably the library you want to look at.